Welcome to 4.7a, Law of Sines Notes. We're going to start these notes with a review problem or two. These should be pretty easy at this stage of the game. We're going to go ahead and try to solve each one of these triangles. And what that means is find all the missing sides and find all the missing angles. So this one on the left, that's easy because, well, the angle part is easy because we know if this is 49 and this is 90, then this has to be, well, whatever adds up to 90 with the 49. 41 degrees plus 49 degrees adds up to 90. That's going to give us the 90 plus 90 is 180 for the triangle. Then on to find the sides, but we know about the trig functions. For example, we know 49 is opposite the f, and the 26 is the hypotenuse. Then opposite of our hypotenuse is the sine, so we'll take the sine of 49 degrees. And we know that that's equal to f over 26. F over 26. So f equals 26 times the sine of 49 degrees. It says to round side lengths to the nearest tenth, so we pull out the calculator and we type it in. Make sure your calculator is in degrees mode because the 49 is measured in degrees. And my calculator is telling me that this is 19.6224, or just plain 6. Whatever the unit of length is for this particular problem. To find h, we could go to the Pythagorean theorem, which is fine. Just be careful not to round your value of f when finding h. We don't want a dirty problem. I'm not going to do it that way, though. Pythagorean theorem is great, but I'm going to stick with trig and realize that the h that we're looking for is adjacent to our angle of 49 degrees. So cosine of 49 degrees equals the adjacent over the hypotenuse, and then we get 26 cosine of 49 degrees is my value for h. Once again, typing that into the calculator will give us 17.057, so that would round up to 17.1. So we have solved that triangle. The next triangle, kind of the same idea, except we don't have either of the acute angles. So let's start with the one unknown side. We know that 1 squared plus y squared equals 4 squared, or y squared equals 15. So we know that y equals the square root of 15, because we're all experts at the Pythagorean theorem. So the square root of 15 as a decimal, my calculator tells me, is 3.87. So 8 rounds up to 9. And that is the length of side y, or wx, if you want to call it that. Angle W is right here. And I'm going to use the 1 and the 4 because those were given. I know that they're right. I might have made a mistake with that 3.9 or the square root of 15. So it's better to use the given information when you can. 1 is opposite W, and 4 is the hypotenuse. So that looks like a sine problem. The sine of W equals opposite over hypotenuse, or W equals the inverse sine of 1/4. And again, I pull out my calculator, and my calculator will give me the answer of 14.4775. It says to round to the nearest degree, so I guess I'll just leave that as 14 degrees. It's approximately 14 degrees. And if we know what W is, then we can find Y pretty easily just by subtracting from 90. So 76 is apparently what the value of Y is. All right, so that's a quick warm-up. What happens if the triangle is not right? That's a special name called oblique. And we cannot use SOHCAHTOA on here because SOHCAHTOA only works for right triangles. So we're going to try to figure out how to deal with your generic oblique triangle. So Here's triangle ABC. We're going to draw the altitude from point C. You should probably try to do this without listening to me first and then check your work. So I'll try to go kind of quickly here. The altitude should drop down like this. We're at a right angle. That's what altitudes do. Put an H there. And this is the height of the triangle. We have two right triangles now, one on the left, one on the right. The one on the left has the angle A. Sine of A equals opposite, which is H, over hypotenuse, which is B. Sine of B is opposite, which is H, over hypotenuse, which is A. And those are two different equations that both have H in it. So we will solve each equation for H. We know that H equals B times the sine of angle A, but we also know that H equals A times the sine of angle B. And since H must equal H, we know that B times the sine of A must equal A times the sine of B. This is true for every triangle, not just for right triangles, but every triangle, because we started with just a generic triangle. It says to divide both sides by the side lengths. Well, little a and little b are the side lengths, so I'll divide both sides by A, and I'll divide both sides by B. And over here, the b's cancel out, and over here, the a's cancel out, and we've got the sine of A over A equals the sine of B over B. How nice. This pleasingly symmetric proportion is called the law of sines. Since we could have started this process by drawing any of the three altitudes of the triangle, we can do a very similar process to show that that third ratio, sine of C over C, is also equal to those other two ratios. So the law of sines states that for every triangle, the sine of an angle divided by its opposite side is constant no matter which angle side pair you pick. Hooray.